Screen printers have many choices of inks to utilize in their process. UV inks, water-based inks, plastisol inks, specialty inks, solvent-based inks. There's many varieties to choose from. One of the variables in the screen making process is how thick do I make my emulsion to create that stencil with which I'm going to print the ink through. One of the guidelines that we use, and this is a general rule of thumb, as I mentioned, there's many different applications and maybe different stencil making techniques, but as a general rule of thumb, we hone in on two different target thicknesses depending on what we're printing. If we're printing fine detail or UV inks, we want to make the stencil a little bit thinner. So we take a ratio of the fabric thickness and multiply that by about 10%. And that equates to your emulsion over mesh, or what is commonly referred to as EOM, as stencil thickness on the substrate side of the screen to form a nice gasket seal for the ink. If we're doing multi-purpose inks, solvent-based inks, plastisol inks, non-critical line work or process work, you can use a little bit thicker stencil, and we use a ratio of about 25% of the total fabric thickness for emulsion over mesh or EOM. Now that we know we have a couple of guidelines as far as stencil thickness, depending on what we're printing, we want to establish a coating procedure that will accommodate that target stencil thickness. And to eliminate the trial and error of going through several screens and coating with different techniques and then measuring those thicknesses to find our target thickness, what I want to show you is a method of step coating the screen. This is for a test screen, so that we can then hone in on the actual target thickness that we're looking for with less labor involved. So what I'm going to do is coat the screen. I'm going to apply 2 coats from the substrate side so that I get the emulsion to completely surface on the squeegee side. Remember, taking all the air out of the mesh openings. And we'll rotate the screen to the squeegee side. And begin to do a step coating. And what I mean by a step coating is I'm going to apply different coating techniques all on the same screen. So thus far I have 2 coats from the substrate side, 1 coat all the way up from the squeegee side. Now I'm going to go 2/3 of the way down the screen. I won't begin at the very bottom. I'm going to start 2/3 of the way down. Apply a second coat. And now I'm going to start 1/3 of the way down the screen and apply a 3rd coat. So at this point, with just 1 screen, I have a 2 and 1 coating, a 2 and 2 coating, and a 2 and 3 coating. This one being thinner, thicker, thickest. What I'll do now is dry the screen horizontally, substrate side down. We want to dry it horizontally so that the emulsion dries evenly. Substrate side down, because that's where we want the stencil thickness to end up, so that we can form this gasket seal. Okay, we've done a step coating test, partially. We have coated the screen with a 2-1, 2-2, and 2-3 coating technique. At this point I want to measure the stencil thickness and the stencil smoothness. And to do this I'm going to utilize a stencil thickness gauge. This is the Kiwo micron meter. Works off of magnetic induction principle, and I use a metal base plate with a free-flowing probe. Placing the metal plate underneath the mesh, I simply place the probe onto the base and it'll give me a reading of the mesh. I take a few readings to get an average. Mesh is measuring 42 microns. So what I can do is actually document this information on the screen. Mesh, 42 microns. And then I'll go into the first coated area and take a few readings, and I'm getting 47 is my average, so I take the difference between 47 and 42, which is the mesh, and I come up with my EOM, which stands for emulsion over mesh, which is 5 microns with my 2-1 coating technique. My 2-2 and 2-3, we'll measure those to see where they read. 52, 52, 52. So I'm getting 52 minus 42, my mesh thickness, gives me an emulsion over mesh of 10 microns. And I'll measure the third coating area, 60 and 60. Okay. 60 minus 42, which was the mesh thickness, is 18. Emulsion over mesh, 18 microns. Okay, now I want to measure the surface smoothness of the emulsion. We measured the emulsion thickness. Now I want to measure the smoothness. The smoothness is measured using an instrument called a profilometer, profile-o-meter, in other words, measures the profile. This instrument has a drive unit, and it utilizes a diamond tip, like on a, say, a stylus on a turntable would have, and this free flows up and down, and the drive unit pulls it into the mechanism. So when I place it, we do like to keep it at a constant angle, at a 22.5 degree angle to the mesh, so that we don't cross all knuckle, but we cross both knuckle and mesh opening. So I'm going to place it on this protractor at 22.5 degree angle, and I will start it. If you can zoom in, I don't know if you can see that probe moving into the gauge or not. When it completes its measurement, it'll push it back out to the starting point. It gives me a digital readout of the surface smoothness in microns. And I can print that out. And if you take a look at this, this is a microscopic view of the surface of the emulsion coating. It looks kind of like an EKG, electrocardiogram, that you'd take in the hospital for your heart rate, doesn't it? But you can see on a microscopic level the peaks and the valleys. The peaks would be where the mesh intersects one another, the threads intersect, and the knuckles of the mesh. The valleys would be the mesh openings where the emulsion shrinks back into the mesh itself. Okay, I've placed all three tapes next to one another to show you the difference between the smoothness of the emulsion coating with a 2-1 coating versus a 2-2 and a 2-3. This one illustrates the roughness of a 2-1 coating. The RZ value is 8.7, and you can see how rough this stencil is. This one is a 2 and 2 coating, 2 from the substrate followed by 2 from the squeegee side. It has an RZ value of 5 microns. You can see it's a bit smoother. And this one is with a coating of 2 and 3, and it has an RZ value of 3.2. So you note the differences. And so I will mark those on the screen. Two 1 coating had a 8.7 RZ value. 2 coating had an RZ value of 5 microns. 2 3 coating has an RZ value of 3.2. Okay, so if you'll notice, my 2-1 coating had 5 microns of stencil thickness with a smoothness of 8.7 microns. 8.7 microns is the indication of the difference between the peak and the valley. Actually, it's the average of 5 independent readings of peaks and valleys. The thicker we coat, notice with a 2 and 2 coating, we increase our stencil thickness and improve or lower our RZ value. The lower the number, the smoother the surface. And with a 2-3 coating, we've increased even more on the stencil thickness to 18 microns, and the RZ value, or the surface smoothness, is improved again down to 3.2 microns.